Hi everyone, my name is Shweta. I'm here to present my assignment for Python programming. Let's start by running the code, which is for planet analysis. So this is my first plot for noiseless time series plot. You can see the transparent curves for daily distances, horizontal dashed lines for average distances. This is my second plot for noisy time series plot. I will be presenting the plots for each s values. This is s equal to 0.5. You can see the different plots for s equal to 2. This is s equal to 5. This is s equal to 10. So till the time we get further output, I'll explain you the question first, which is distance between Earth and Mars on day 732. Let me begin by showing the distance between Earth and Mars on day 732. I have already created a function called distance, which calculates the Euclidean distance between any two planets using their orbital position. The code for the distance is written over here. This is the function of distance that I have created, and you can see the output that I have printed over here, which prints the distance between Earth and Mars on day 732, which is 6.52 million miles. So this is the rest of the output printed, which is the average distance metrics and closest planet to Earth on average of over 1,000 years, which is Mercury. So the question second is, how do the position and the distance function works? Now let me explain how the position function works. Each planet follows a circular orbit. So I use trigonometry to find the x and y coordinates. So the function for position is written over here. So this is the function for position. I calculated the angle based on the day and the planet's year length using the formula. This is the formula that I have used. Then I used a cosine and sine function from the math module to find the x and y position. So this is the math module for cosine and sine function that I've used. The distance function then calculates the straight line distance using Euclidean formula. So question third is time series and noise analysis. For the 1,000-day simulation, I calculated the day distance between Earth and Mercury, Venus and Mars using loops. I stored these distances in list and plotted them using matplotlib. The clean or noiseless plot shows periodic waves pattern because the planet orbit the sun in cycles. Then I added Gaussian's noise using numpy's np.random.normal function that is written over here. This is the code with a different standard deviation, that is s equal to 0.5, 2, 5, and 10. The, the different noisy versions are written over here. The average distance were plotted as a horizontal dash lines. As the noise increases, the fluctuations grow wider, but the average ranking mostly remain the same. However, when the noise is high, it may temporarily distort the actual closest planet. This simulates real-world sensor inaccuracies in astronomy. So question fourth is 8 by 8 matrix and the closest planet. For the final part, I ran 1,000-year simulation by iterating over 365,000 days. For each pair of 8 planets, I calculated the stored the average distance between them. The result is an 8 by 8 symmetric matrix where row I and column J shows the average distance between planet I and planet J. I used nested loops to fill the matrix and printed it out in a tabular format. Here's the sample output that I was explaining. So you can see the 8 by 8 matrix over here. I then looked at the row for the Earth and found the smallest average distance, excluding Earth itself. Based on the 1,000-year simulation, the closest planet to Earth is, on average, over 1,000 years is Mercury. Thank you.